Hello and welcome to this chemistry lecture series. This is going to be the last video for the chapter 12 series, which is going to focus on chapter 12.4 or the disproportionation reactions. So this is going to look at very specific reactions which the halide ions actually undergo a lot of, as well as the halogen diatomic molecules. So let's get started. So let's start with what is a disproportionation reaction. We talked about disproportionation reactions back when we did redox. Disproportionations are reactions where the same element is simultaneously oxidized and reduced. This means that one element is both the reducing agent and the oxidizing agent. Now, you have to be careful here because a lot of students tend to think of this as the exact same atom getting both oxidized and reduced. And that's not possible. An atom cannot transfer electrons to itself. Different atoms, but of the same element, are going to react with each other, transferring electrons amongst them, giving you two different products, both of which are going to contain the element. So it's not one atom reacting with itself, but two atoms or multiple atoms of the exact same element transferring electrons amongst each other. One atom gets oxidized, gives you one product with the element in it. The other atom gets reduced, gives you the other product with the element in it. So an example of this that we have seen through redox, in the redox chapter, is the disproportionation of hydrogen peroxide when it decomposes. When hydrogen peroxide is H2O2, the oxides have, or the oxygens have, a -1 oxidation number. And that is the only time that you're going to have a -1 oxidation number of oxygen is in peroxide. Well, when the hydrogen peroxide decomposes, two things happen to the oxygens. Some of the oxygens will gain electrons, becoming the oxygens in water, which have a -2 oxidation number. So they're reduced, gaining electrons, becoming -2. And some of the oxygens in the peroxide will get oxidized into O2, or oxygen gas. The oxygen gas will have a 0 oxidation number. And so they increase in oxidation number, losing electrons. So here, both the oxidizing and reducing agent is oxygen. Some of the atoms of oxygen become the oxygen in water, getting reduced. Some of the atoms of oxygen become the oxygens in O2, getting oxidized. And that's why this is a disproportionation reaction. One element acts as both the reducing and oxidizing agent, becoming two different products that contain that element. Now, there's some reactions, there's actually three main reactions of the halide, specifically chlorine, that we're going to now study that are disproportionation reactions. The first is the reaction of chlorine, Cl2, with cold dilute sodium hydroxide. Now, aqueous chlorine will undergo this disproportionation reaction, and we have to pay very close attention to the conditions. In this case, the chlorine, the aqueous chlorine, is reacting with cold dilute sodium hydroxide, or NaOH. Again, the sodium hydroxide here has to be dilute, so it has to be a very low concentration, and it has to be under cold temperatures, 15 degrees or so, maybe a little below that. So when the sodium hydroxide that is cold and dilute reacts with the chlorine aqueous, what happens is a disproportionation reaction which creates sodium chloride, sodium hypochlorite, and water. Why is this a disproportionation reaction? Well, as we can see here, from Cl2, which has an oxidation number of 0, to the NaCl, where the oxidation number of chloride is -1, there's reduction happening. The chlorine gets reduced from 0 to -1, from Cl2 to the chloride ion. But the chlorine also gets oxidized, because that's one chlorine atom from the two in the chlorine molecule that get turned to chloride. The other chlorine atom gets oxidized by gaining the electron that the other chlorine loses. by losing the electron that the other chlorine gains and becoming the chlorine in sodium hypochlorite. In hypochlorite, the chlorine atom has a +1 charge, and so it gets oxidized from 0 to +1. That's why this is a disproportionation reaction, because the chlorine is both the reducing agent and the oxidizing agent. One chlorine gets reduced, acting as the oxidizing agent, while the other chlorine gets oxidized, acting as the reducing agent. Now, this combination that we get out of this reaction is actually very well known. That sodium chloride and sodium hypochlorite combination is what we know as bleach in everyday life. So whenever you use bleach to kill bacteria, to clean your house, what you're doing is you're using this combination of sodium chloride and sodium hypochlorite that's created by reacting chlorine gas, or say aqueous chlorine, with sodium hydroxide. Now, we have to be careful though. This reaction only happens if you react chlorine aqueous with sodium hydroxide that is both dilute, so low concentration, and cold, around 15 degrees Celsius. But if we react the chlorine with hot, concentrated sodium hydroxide, we change not the reactants, but the conditions. We get a different reaction. If we increase the temperature and the concentration, we still get a disproportionation reaction in this reaction. But that oxidation part of the redox reaction goes even further. So if the conditions are hot, so around 70 degrees Celsius or more, and the sodium hydroxide is concentrated, the chlorine will still react with sodium hydroxide, and it will still create the sodium chloride and the water. But the oxidation reaction will not give us hypochlorite, it will give us sodium chlorate, ClO3. So the reduction side is still the same. The reduction is still chlorine going from 0 to -1 in sodium chloride. However, the oxidation now goes from 0 in the chlorine to +5 in the sodium chlorate. So because of this, the balancing changes, because if we use the half reaction method here, the balancing is going to change. Notice how the reactants are the same, but now we have a 3:6 ratio instead of the 1:2 ratio we had with the cold dilute sodium hydroxide. And that change is because now we have to lose 5 electrons from that chlorine that's getting oxidized. And those 5 electrons need to go somewhere, which is going to be to the 5 chlorine atoms get reduced into the chloride atom. So, notice how changing the conditions completely changes one of the products from sodium hypochlorite to sodium chlorate. So you always have to read the question carefully, because when you're reading this AICE exam, with this paper 2 or paper 1, you are going to have questions where they will try to trick you by giving you the same reaction but with different conditions. So be very, very careful in reading the conditions of those reactions. So those are the 2 reactions between chlorine and sodium hydroxide, which have 2 different conditions. Now, there's one other disproportionation reaction that we need to know for chlorine. And that is the reaction that we usually call the chlorination of water. Now, this is a reaction you should be fairly familiar with, because not the reaction itself, but the use of it, because this is what we use to purify water. Both drinking water, the water that comes out of the tap, and pool water are both sanitized through the use of chlorine and the process of chlorination. Chlorination is simply adding aqueous chlorine to water to kill bacteria. So what happens when we add chlorine to water, not sodium hydroxide here, to water, is that the chlorine will undergo, again, a disproportionation reaction. One chlorine atom will react, or we will get reduced into the chloride ion, but there is no sodium here. So instead of creating sodium chloride, we create hydrogen chloride aqueous, or what we know as hydrochloric acid. So one chlorine atom will get reduced from chlorine to hydrochloric acid. The other one will get, I guess you probably guess, oxidized. And again, it will create the hypochlorite ion, just like with sodium hydroxide. But because we don't have sodium, it doesn't create sodium hypochlorite. It creates hypochlorous acid, or chloric 1 acid, which is HClO. Now, this combination of HCl and HClO are what kill bacteria. The HClO created dissociates into hypochlorite ions, HCl minus, and those hypochlorite ions act as sterilizing agents, killing bacteria. So when we add the chlorine aqueous to the water, HCl and HClO are created. The HClO is going to dissociate into H plus and ClO minus. That ClO minus ion that's created goes into the bacteria. It disrupts cell function through a bunch of ways that you do not need to know, like disrupting proteins and breaking it down, breaking out DNA, and that will kill the bacteria, leads to bacterial death. And that's how hypochlorite ions from the hypochlorous acid that is created from the disproportionation of chlorine in water kills bacteria. That is it. That is all of the reactions of the halide ions and the halogen ions that you need to know, as well as a pretty good idea of what disproportionation is and how it applies to the halide ions, specifically chlorine. That is it for section 4 of chapter 12, and that is it for chapter 12. I will see you all in the next videos when we start to discuss chapter 13 and nitrogen. Thank you for watching.